Today's lecture from section 3.4 from our textbook deals with the graph of ax plus by equals c. It is the standard form of a line that you have seen before, but we're going to give you a few shortcuts you can use with it. And we want you to be able to determine the slope and intercepts given the different forms of lines, recognize the properties, and then graph or interpret graphs of the different types of equations. So here we go. If I would start with, find the equation of a line that passes through the blue points. A lot of you would look at them and you would start analyzing and say, well, I've got the point 4, 4, and I have the point 6, 5. So you might do slope to figure it out. You might draw your line. It says find the equation of a line that passes through these points. So if we just did the blue one, for example, we could go with y minus y over x minus x. When we did that, 5 minus 4 is 1, 6 minus 4 is 2. We would get a slope of 1/2, rise over run of 1/2. But knowing that could go into our equation y equals mx plus b for the m value, that would leave us no b. We do have ordered pairs of x, y, so it would be a good idea to take one of those ordered pairs and put it in for the x and the y. I'm going to choose the 4, 4. So 4 goes in for y, and 4 goes in for x. That will help us solve for b. Half of 4 is 2. That 2 will come over to the other side and be subtracted. We'll end up with 2 equals b. So with that, we now have a final equation we could write using the blue points only. Y equals 1/2 x plus 2. And you would have an equation in slope-intercept form of that line. Now, we're going to learn in this chapter that there are other forms that might be readily available to be used better than just our slope-intercept form. So you could do the same thing with the red points. Slope would be different. You can see that that one rises faster than it runs. But here's an example of how you could get a equation from just given 2 points. Next one, if we look at the points A, B, and C, and they're all points on the same straight line, and we were given the point A was 2, 2, and the point B was 4, 3, and then C is on this line somewhere, and it has the coordinates 100, comma, E. And they say, well, what's the value of E? Again, you're going to be going through the process of, well, E is a y value. So if we started with the 2 that we know, y minus y over x minus x, 3 minus 2 is 1, 4 take away 2 is 2. The slope of this current line is to rise 1 for every run of 2, or the slope of 1/2. So if we went and again put it into our y equals mx plus b equation, we would not have a b value. In this case, we're going to need that b value. And some people say, well, you can see that the b value is 1. Well, you can graph it, or you can do what we did. You can get it by graphing, eyeballing, or you could get it by doing what we did last time, and that is put in another xy value. But we can see it on our graph this time, so let's take it from that. If y equals 1/2 x plus b, our b value is a 1, our y-intercept, we now have an equation, but that's not what this one's asking for. It's saying, what is that value of e way out there? So if we knew somewhere out here, 100 something, so we got to look at the 100 is our x value, the e is our y value. So we would put 100 in for x, leave the e as our unknown, and again, do the arithmetic. Half of 100 is 50, 50 plus 1 is 51, so we should get y equals 51. So when c is 100, e should be 51. another way to find points obtained on a line given some information. Now on this one, you should be able to name these based on their y-intercepts, their slopes, the tricks we've used before as an example. So let's go red this time, and let's just say we know our equation is based on y equals mx plus b. We can see our y-intercept, and we should be able to see the slope quite easily. So let's look at our red line, our red value for our y-intercept. We can see here is a -1, so b is -1. And now we just have to look at our red line carefully and come up with 2 points that would give us a good eyeballing of our slope. And I believe our point of 0, 1, and now our point of 2, 0 are up 1, rise 1, run 2. And so that's a 1/2. So we would have y equals our slope of 1/2 x, and then our y value, y-intercept, was a -1. So I don't know what I was trying to write here. Well, let's just go with y equals 1/2 x minus 1 would be the equation for our red line. You could do that with the blue one, the black one, etc., based on ways we have used our lines in the past. We could do the same thing here. All these lines go through the point 2, 2. Can you label them correctly? Name them. Can you draw a similar diagram with 6 other lines that go through a different point? Those are all situations you should be able to do now based on your knowledge and characteristics of lines. Here are 3 different forms of lines, so let's just review them real quick. Y equals 3/5 x plus 5 down here is our slope-intercept form. You should be able to see the slope and the y-intercept immediately by looking at the equation in the form y equals mx plus b. If we go up here, x equals 5, you should know that is a vertical line. And over here, y equals 10, you should now know is a horizontal line. Now, when we talked about y equals mx plus b, we were able to say the slope is 3/5, it's the m value, the y-intercept is b. Up here on the vertical line, we know on all vertical lines you have a rise forever and you have no run. So we were saying that the slope of a vertical line is that there is no slope. Undefined, some people would say. On a horizontal line, we say we run forever, but we don't rise at all. So rise over run. Rise is 0 and run is whatever it is. And so we have a slope of 0 in this case. You should have those memorized at this point. And now we're going to work with our last form, which is that standard form that we haven't done a lot with yet, other than identifying points, which will be key. This example is just that. Identify the ordered pair for each labeled point and where it is located in the coordinate plane. Do not forget your quadrants. Do not forget what an intercept is. So as you go through these, make sure you're realizing this is quadrant 1, upper right-hand corner. Upper left-hand corner is quadrant 2. Lower left-hand corner is quadrant 3. And lower right-hand corner is quadrant 4. That also leaves points that lie right on the axes, and those are x or y intercept possibilities if you're right on the axes. The x-axis obviously is x intercepts, and the y-axis is y intercepts. There's only that one point, 0, 0, that can be an x and a y intercept. So with that, moving forward, if we would take our standard form of a line and work with it on our equations, we should be able to see some characteristics. Now, in your reading, you were able to, so I'm going to go through something quickly with you, and we'll see if you saw it. So here is, we'll start with a standard form of a line. Ax plus by equals c. No numbers at all. And we're saying every time we did this, most of you would take what was standard form and you would rewrite it so that y was by itself. You would get it into slope-intercept form. Well, I'm saying this is the section where you should learn that you never have to do that again, because there are some shortcuts that get you there quickly. So let's try and see what happens in generic form and then see if we can use that to carry it over to all equations in standard form. So ax plus by equals c. First thing most of you did was you got rid of the ax term by subtracting. And so you see that on both sides here. Next, whatever the b value was, you would divide. So we would get y by itself. When we got y by itself, if we even wrote it in slope-intercept form and put that a over b x value first, because we want our y equals mx plus b is how a lot of you have it memorized. So if we do now if we look at that, we now have the equation y equals the opposite of a divided by b times x plus c over b. Now again, remember, this goes back to y equals mx plus b. So we should be able to look at this and say, well, wait a minute. That should mean that our m value, our slope, is really that number in front of that x. That number that stands by itself is really that c over b. So if you didn't draw those conclusions, let's draw them together now, and that is that our slope is really the opposite of a over b, and our y-intercept is that c over b value. So the next normal question is, well, what is the x-intercept? Well, remember, in slope-intercept form, the y-intercept is never there. But there is a little trick we can use to help us get there. So follow me on this one. X-intercepts. Since all x-intercepts are in the form x comma 0, every point that's on the x-axis, we'll place a 0 into our standard form equation for y, and we'll do the math. As you know, b times 0 is 0. Ax plus 0 is just ax. We'll divide by that a value to get x by itself, and we will end up with x equals c over a. So we just said in standard form the x-intercept is c over a. If we go back and add the other two, the y-intercept was equal to c over b. And our slope was equal to the opposite of a over b. These are three shortcuts which you will now be able to use every time you see standard form, and they will definitely be shortcuts. You will not have to do the rewriting that you've done before. So let's play with them and show you how they're going to be used in our next statement. Okay, now again, let's put our little shortcuts over here. Slope was equal to the opposite of a over b. X-intercept is equal to c over a, and the y-intercept is equal to c over b. Now if you look at these real carefully, it might be easy to get a memorized slope, alphabetical order, opposite of a over b. We like to say opposite of a because then you're not thinking negative. And then x-intercept, x comes before y, and notice they both start with a c on the top, but x comes before y and a comes before b, so c over a, c over b, you've got your x and y intercepts quite quickly. All right, here are three equations. Two of them are in standard form. So if we go and use our work that we just did, our slope, y-intercept and x-intercept, and don't rewrite these and get y by itself, we should be able to quickly, as quickly or quicker than we would write y by itself, be able to state what these three values are. So here we go. If we said our slope, m, is equal to, you look at the equation, you find a, you find b, and you find c in your standard form equation. Slope is the opposite of a over b, so we'd be looking at opposite of a would be -3, over b is -2, and you know that a negative divided by negative is a positive. So our slope is 3 over 2 in this case. Our x-intercept is c over a, so 8 over 3. That's lowest terms. We're good there. Our y-intercept, c over b. And if we reduce that, we get a -4. So very quickly we have all three values. You wouldn't have gotten all three values when you used the slope-intercept form, but now we have it. Let's try another one. Slope equals opposite of a over b. Reduce that. Our slope is 1/2. C over b, or c over a, your choice. If we go c over a, which is the x-intercept, we would have to do 12 over -2, which is -6. So we know we have an x-intercept of -6, 0. And then that leaves c over b as our last thing, which is our y-intercept, 12 over 4, which reduces to 3. So we have a y-intercept of 3, which means the ordered pair 0, 3. Now, this last one is not in standard form, and you can get a slope quickly out of it. You can get a y-intercept quickly out of it. You cannot get your x-intercept. Now, you could do the x-intercept two ways. You could either rewrite that in standard form and then use your A, B, C numbers that correspond. And if we were looking for the C over A, which is your x-intercept, in this case, we would have had, in this case, C is -5. A would have gotten moved to the other side. It would have been a -3, and we would have ended up with 5/3. So you could still do that fairly quickly. You wouldn't need the other two because they were already here in slope-intercept form. So you have some choices now, and you don't have to rewrite the equation and get y by itself. So knowing that, you, I believe, have all the shortcuts you need to move forward. The only other thing would be, what do you do if you graph these? And so a quick graph would give us, in this case, let's go with this one here on the right, 3y minus 2x equals 18. So you're thinking, okay, first I really probably need to rewrite that. Yeah, you're going to say, okay, my slope is, this is standard form, so be careful. Slope is opposite of a. Your a value is the number in front of x, so 2 over b. Your b value is 3. If we want our x-intercept, then that's c over a. C is 18. A again, -2. And reduce. And then your y-intercept, c over b. And b in this case is 3. So reduce that, and you're good to go. Look at your equations. You could graph your x and y-intercept. You could have your line drawn, and that's all you would need. You wouldn't even need that slope. So you could go x-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9. -9 is one of the points. And then your y-intercept, 1, 2, 3, 4, 5, 6 is a second. Graph your line with those 2 points only, and you should be good to go. There would be the graph of your line. Now make sure your line goes through your points, and if it doesn't, straighten it out, and you should be good. So, all new equations. We have really several different ways to write our lines, including standard form now, which has some shortcuts, which allows us to get our slope, our x-intercept, and our y-intercept without having to rewrite equations. So bring any questions you have about that to class, and we'll see who still has some questions or confusion.